All right, welcome back. We are getting in these last couple of examples for these binomial probability distribution applications. Are 16% of M&Ms green? Mars Incorporated claims that 16% of its M&M plain candies are green. A sample of 100 M&Ms is randomly selected. Find the mean and standard deviation for the number of green M&Ms in such groups of 100. Same as before, right? So now we know, hopefully, from this that n better be 100. And so what about p? What should p be for this one? Well, the only percentage we got is 16%. Let's write that as a decimal though. And we know we're going to need q, so it probably doesn't hurt to write down our q. So 1 minus that, which is 0.84. All right, so we got our mean, or excuse me, our NP and Q. So let's look at our mean first. So we got N times P, 100 times 0.16, which is equal to 16. 16 what? Remember, it claims that 16% of its plain M&M candies are green. So this would be green M&Ms. All right. And then for standard deviation, so we got 100 times 0.16 times 0.84. So let's get our handy dandy calculator. So we got 100 times 0.16 times 0.84 equals that, and then we got to square root it. So 3.66606, blah, 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 blah. All right, rounding, no decimal points, let's go 1. So 3.7 green M&Ms. All right, let's see what the second part wants. Data set 27 in Appendix B consists of a random sample of 100 M&Ms in which 19 are green. Is this result significantly high? Does it seem that the claimed rate of 16% is wrong? Well, so if we're looking at significantly high, it'd be nice to have some cutoffs, right? Now remember, we can use probabilities, but it's a little bit clunky, and we got this nice information right here. Let's use the range rule of thumb instead. So let's get our min and max significant values. So we got 16 minus 2 times 3.7, which is equal to, well, let's be safe. Put it in the light. 16 minus 2 times 3.7 equals 8.6. So we got 8.6 green M&Ms. And, well, we know the other one's going to have to be plus, right? So plus 2 times 3.7 equals 23.24. So we got 23.4 green M&Ms. So what does this tell us? What do we know about 19 then? Is 19 significantly high? Well, compared to our cutoffs, we can see that 19 has to be between them. And if it's between, that means it's not significantly high, because 8.6 is the lower and 23.4 is the higher, and 19 falls right in between those. So we know it can't be significantly high. It's not significant. All right. So that's not unusual. Does it seem that the claim rate of 60% is wrong? No. 19 falls in the non-significant range, meaning between those two cutoffs. So we're good. All right, let's try this last one, which has 4 parts to it. Oh boy. So, excuse me. Job longevity. A headline in the USA Today states that, quote, most stay at first job less than 2 years, end quote. That headline is based on an Experience.com poll of 320 college graduates. Among those polled, 78% stayed at their first job for less than 2 years. Okay, so again, that's most. That's more than half, so most. Assuming that 50% is the true percentage of graduates who stay at their first job less than 2 years, find the mean and standard deviation of the number of such graduates in randomly selected groups of 320 graduates. Okay, so mean and standard deviation again, but we're not using the 78, we're using 50% as the true value of P. So in this case, N is 320, P is 0.5, which means Q is 0.5 also. All right. So our mean better be 320 times 0.5. Well, half of 320 better be 160. So 160 graduates. So 160 grads. All right. And then our standard deviation so we got N times P times Q. So we need the square root of 80, right? So 160 times 0.5 is 80. Square root of 80, 8.944. So we'll round that to 8.9 grads. All right, so not too bad. Assuming that the 50% rate in Part A is correct, find the range of significant values for the number of graduates among 320 who stay at their first job less than 2 years. So range of significant values. So min and max usual values is what we need. So our min significant is 160 minus 2 times 8.9. I might as well do the max at the same time. So 160 plus 2 times 8.9. And so what do we get for those values? 160 minus 2 times 8.9 equals 142.2 grads. And then 160 plus 2 times 8.9, 177.8. All right, same stuff as before. Well, let's see how it changes up a little bit. Find the actual number of surveyed graduates who stayed at their first job less than 2 years, using the range of values from Part B to determine whether that number is significantly high, significantly low, or not significant. Does the result suggest that the headline is not justified? Okay, so we need to find the actual number of surveyed graduates who stayed at their first job less than 2 years. So keep in mind what they said at the beginning. We know that there was 320 that were polled, and 78% of them stayed at their first job less than 2 years. So 78% of 320, which equals what? Well, remember, we can just flat out multiply this. Change this to a decimal, multiply by 320, and that should give us our result. So 0.78 times 320 equals 249.6. So 249.6. Now we're talking about people here, so we probably would want to round this properly. So let's round this up to 250 grads. So that's the number of graduates who said that they stayed at their job less than 2 years. Now, what do we know, or what can we say about this significantly high, low, or not significant? How does this compare to our cutoffs? Well, our maximum is 177, and this is way much higher than that. So 250 grads is significantly high because 250 is greater than 177 point, whoops, not 6, 8. So that justifies why it's significantly high. And now the final question says, does the result suggest that the headline is not justified? Well, what do you think? Because this is an abnormality, we would typically not see that many. We would typically see somewhere between here and here, and there's probably something fishy going on. So probably not, whoops, justified. So let's see what the last part says. This statement was given as part of the description of the survey methods used. Alumni who opted in to receive communications from experience were invited to participate in the online poll, and 320 of them completed the survey. What does that statement suggest about the results? What kind of response is that? Hopefully you're screaming at me. Voluntary. This is a voluntary response sample. And we've already shot those things down, right? Because there's bias. What else is wrong with that? There's probably bias, but there's also maybe there was some incentive to respond. Maybe they worked for experience, they had their degree, they worked for experience, they said, maybe I should participate just so that way they have enough information. So there's probably some bias associated with it. What else is wrong with it? Well, alumni who received communication from experience. So you had to have communication from experience. So had to be subscribed to experience. Only 320 of them responded. Is 320 a big sample size compared to all the graduates, the college graduates? Not really. So again, small sample compared to population. So there's all kinds of flaws in this survey. So that's one of the things you have to be skeptical about when you see those online polls on television. Oh, here was this poll. Well, you should be asking, who did they ask? How many people are in the sample? Was it a voluntary response sample? All of those things are very important when you view data online or on the television. Chances are there's something fishy going on. Small sample size is usually the biggest problem. If you do the research and actually dig in, you'll see how small those samples actually are. So, all right, that wraps up this section. And there's going to be some tables. You don't need to bring your textbook, but there's going to be some tables that you're going to see in the next chapter. So, but that's a little bit away. So we'll see you very soon. Take care.